Welcome to using the product rule. So we saw in the last video where the product rule comes from. Now we have the product rule, we can go ahead and use it. We no longer have to use that limit definition. So again, recall from our previous video that if we want to take the derivative of a product of two functions, we can take the derivative of the first, multiply it by the second, and then add to that the first times the derivative of the second. So, oops, sorry about that. Let me shift that row down. So again, we do f prime of x times g of x plus f of x times g prime of x. So in this first example, we have find the derivative of f of x equals x cubed times sine of x. This essentially is acting as my f, and sine of x is essentially acting as my g, right, in our product. So if I want to take this derivative, then what I'm going to do is f prime of x is equal to the derivative of x cubed times the original second function, times sine of x. And then to that, we are going to add x cubed times the derivative of sine of x. So this becomes 3x squared by the power rule times sine of x plus x cubed times the derivative of sine is just cosine of x. So I like to do some sort of notation just to remind myself that I still need to take derivatives, whether I use a different color, whatever we use, just to remind ourselves that we still have derivatives to take. Once you've taken those derivatives, then we're set. You may need to do some simplification. In this case, we're as simplified as we can get. All right, so our next function, we have g of x equals e to the x times cosine of x. So again, we're going to do, oops, g prime, not x. G prime of x is equal to, we need to take the derivative of e to the x, the first function, and then multiply by the second function. And then to that, we will add the first function, e to the x, times the derivative of the second function. So the derivative of e to the x, we know is simply e to the x. And we have e to the x times cosine of x plus, now we have e to the x times the derivative of cosine of x, wound up being negative sine of x. And then if we do a little quick simplification, this becomes e to the x cosine of x minus e to the x sine of x. So the derivative of e to the x cosine of x is e to the x cosine x minus e to the x sine of x. And last up, let's go ahead and find the derivative of h of, I seem to change variables on myself. Let's do h of x equaling x squared times e to the x times natural log of x. So here we have three products, or three things involved in the product, three factors. So let's go ahead and focus first on x squared times e to the x natural log of x. So we have h prime of x is equal to, we'll do the derivative of x squared times e to the x natural log of x. Then to that we will add x squared times the derivative of e to the x natural log of x. Now, this first derivative we can go immediately through. So the derivative of x squared by the power rule we know is simply 2x. So we have 2x and then times e to the x natural log of x. For this one on the right, we have plus x squared, then we have times, we have another product, e to the x times natural log of x. So doing the product rule one more time, we would have the derivative of e to the x. Oops. So the derivative of e to the x times the natural log of x. Then to that we will add e to the x times the derivative of the natural log of x. Sorry, that got a little squished. So we have 2x e to the x natural log of x. Then we have plus x squared times derivative of e to the x is simply e to the x natural log of x plus e to the x, and the derivative of natural log of x, again, that was one of our special functions, wound up being 1 over x. Now, if we go ahead and just distribute in the x squared, we have 2x e to the x natural log of x plus x squared e to the x natural log of x plus x squared e to the x times 1 over x, or we could just put it over x. Technically, we could simplify that last one, x squared over x. So this is 2x e to the x natural log of x plus x squared e to the x natural log of x. And then this would just be plus x e to the x. Technically, when we cancel, we need to keep record. So we canceled out an x and an x squared here. So we would say x is not equal to 0, but we already know that. Right? So natural log of x already requires x greater than 0. And so we don't need to write that in this case when we did our simplification. So typically when we simplify, when we cancel things from a denominator, we lose information about what x cannot equal. But again, in this case, natural log of x already requires x greater than 0. So we didn't lose any thing from our domain or any information about our domain. So that is using a product rule. This last example was using a product rule repeatedly. We could do the product rule over and over and over again if we have more than 3 factors. Right? Anyways, that is the product rule.